So what I have here is measured data from an LED going into a light pipe, and I'm looking here at the output of the light pipe, and I'm looking at the luminous intensity, the angular response of this light's output, and it's basically very broad. It's something like about 50 degrees that it's coming out at, and my goal here is to design the light pipe that gives me the most directional beam I can get. So you'll see I'm getting about a peak intensity of about 5 10 to the minus 1 lumens per steradian, but that's a kind of a noisy peak. But roughly speaking, if you kind of average this out a little bit, so maybe we just add a little bit of smoothing in here to round out the noise, then I'm getting something like 0.37 or so of the of a lumen here. I'm firing a total of 1 lumen in here. So what I want to do is to get the best possible light pipe here, and to do that I've built a merit function using the optimization wizard. And what I've told it is that I want the smallest angular radius, in other words angular radius equal to 0, with a minimum output of 1 lumen, and I've set the source to be 1 lumen. So this is basically saying give me as much power as you can without losing as much power as possible. So now that I've done that, let me set up the optimizer and have it run. So I'm going to set the optimizer. I'm going to use the orthogonal descent optimizer. I'm going to run it over 5 cycles, and I'm going to let it fire away. And what OpticStudio is doing now is it's ray tracing through this design and perturbing the freeform optic that we have in such ways to see which way gives me the best angular radius, the smallest angular radius as an output from this light pipe, but also conserves power. And you can see that already it has made a fairly substantial improvements with the merit function falling by almost a half just within this first cycle. So what I'm going to do is pause the screen capture whilst the cycle cooks, and then we'll pick it up again after each cycle has finished. So we're currently here at cycle 1 of 4, about 47 seconds in. So we're now into the second cycle of optimization, and it's about the 2-minute mark. You'll see that the merit function has fallen substantially as a result of that, and you'll see that we've now got a peak intensity of about 10 times what the original peak intensity was. You can see that this angular distribution is much narrower than it was. I can't move on to any of the other windows right now whilst this window is running, but this is showing that the angular radius of the outputs from this light pipe is substantially better than it was. You can see that the light pipe has become narrower at this end. It's losing some of the high angle light, but the lower angle light is now being guided through the light pipe and is now giving me a much smaller angular radius at the very output. We'll come back to this at the end of this cycle. And here we are at the end of the second cycle now. You'll see we're starting on to cycle 3, step 2 now. You'll see that the angular spread of the power has continued to increase. We've now got a kind of a ghost ring in angle space and then a dark ring here, and we're starting to get a bright central point. So we're starting to get a very intense low angle power coming through this light pipe. We'll come back after the end of this cycle. And here we are now at the end of the third cycle, so we're just going into the fourth cycle. You'll see the merit function continues to drop substantially. The pipe is taking a more subtle shape as the light is guided to the output. You can see that the scatter ring that we were getting is substantially reduced. We're getting more and more power coming into this central region. We're now up to a peak power of a peak intensity of 5.8 lumens per steradian, so that's substantially up on the approximately 0.3 or 0.4 that we were at the start, and the optimization's got one more cycle still to go. And now here we are after the end of the 5th cycle. The whole process has taken 9.4 minutes, so just under 9.5 minutes. The merit function has reduced substantially from its starting point. We can see the shape of the pipe that has been designed has been such that it throws some of the high angle light out but captures most of the light and gently tapers and guides it through this pipe such that it comes out 64% efficient but into an 11 lumen per steradian peak. No secondary ring here at all. If we look at this as a cross section, we'll see that that's a nice, really nice looking cross section for the output from this little LED flash lamp. And we can go back and compare that to what we were getting originally. This was the original starting point that I stored. This is what we've optimized it to in just under 10 minutes.